Hello everybody, I'm Vignesh. Today I'm going to be solving the integral of 2x squared plus x plus 1 over x times x plus x squared plus ln of x squared. So someone sent me this really interesting integral and I think it can be hard to find out at first, but just need to use a lot of it's a lot of how your knowledge on the different methods, and you can solve from there basically, because that's how you can find the first crucial step, and it's easy from there. So first you can see, of course, you may want to try expand this, but it's just and make by parts, and that it looks like that's probably going to be the only way originally, but it's definitely not. That's definitely such a hard way. If you had like all the time, yeah, maybe you could try it, but definitely not recommended. Now, usually, you can see when there's a fraction, it's usually anything by parts, but has to be by expanding. The other thing is usually u sub. And there's a reason, because u sub, usually when you're going to have some part of u on the denominator, and then du on the top, and you go from there. And that's how it usually is. So, let's think about some things we can use in u sub. So we saw the u is usually on the bottom and d is on the top. So let's think about just this part in general, because definitely I don't think you probably do not want to take the u is probably not something as complex as squaring it or even timesing it by x. So what we can do is we can find the derivative of that. So if we set u equal to x plus x squared plus ln of x, then d of u is equal to, well, we can find the derivative of each term. So it's going to be 1 plus 2x plus 1 over x. But for purposes, I'm just going to do it like in degree order of x plus 1 over x. And then, of course, and that's, and yeah, sorry, and then dx. Wait, no, yeah. Well, usually, yeah, the formal way of doing u substitution is actually like solving for dx and stuff like that. But really, this is for like advanced u substitution, it's usually just something simple, like not really caring about the du in general. But yeah, but the formal way is doing it that way. So I'm not actually really strong in that. I kind of forgot how to do it like that because I've done a lot of u substitution. Well, if du is equal to 2x plus 1 over x, how does this even relate to the top? The top is 2x squared plus x plus 1. You may not know this, but if you times this whole expression of du times x, it'll become 2x squared plus x plus 1. And that's that. So the numerator is just x times du. So I'm going to move this here. So it's going to be x times du over, remember we still have an x there because we set that equal to u. So it's going to be x times, and you set this to u squared. Now we're going to quickly cancel these off. So it becomes du over u squared, which remember the du will just carry on to like the regular integral, because the integral form is integral of something du dx, but then du replaces that because we're using u sub. And then it's going to just be 1 u squared du, and you will find the integral of that. This can be easy because it's going to be u to the negative 2, so it's going to be u to the negative 2 plus 1 over negative 2 plus 1. So that's just equal to negative 1 over u. So that is basically what we do, but we have to sub in our u again, which was, remember, x plus x squared plus ln of x. So this becomes negative 1 over x plus x squared plus ln of x. And that is our integral of the integral of 2x squared plus x plus 1 over x times x plus x squared plus ln of x squared is equal to negative 1 over x plus x squared plus ln of x. Thank you for watching this video.